MacMaths, let's do some maths today. Turn the page off. Okay guys, so today we're going to look at the cast wheel, and I'm going to show you how a simple wheel can replace all three of these diagrams: the sine curve, the cos curve and the tan curve. Okay, it's what proper mathematicians use in order to solve equations, to make the maths sort of easier to understand and to work out solutions. Mr. or Mr. Darren may not use the cast wheel, but then I would not class them as proper mathematicians. Okay, so when I say replace these three graphs here, I do use these three graphs, and I do draw the sine curve, the cos curve and the tan curve for specific values. Okay, so if I want to know what the sine of 90 is, I draw the curve to remind me that it's 1. So for these limits, you know, I do draw the curves, you know, when I'm trying to work out what the cos of 180, to remind myself, you know, I'll just quickly draw this curve to remind myself that the cos of 180 is -1, and so on. You can see here on the tan, you know, I've got my asymptotes in. Okay, so I'm going to start off by drawing the cast wheel. Okay, so I'll draw it on this side here. In fact, yes, that's exactly what I'll do. Okay, so I'll draw a nice wheel, like that, a nice circle. I'm fairly good at drawing the circles, and we'll put a cross in. This cross here represents the x-axis, and the way that the cast wheel works is it goes through the 4 quadrants, and it describes the angles created as you go round from 0 degrees to 90 degrees to 180 degrees, 270, and then back up to 360. So it turns in this direction. We call it the cast wheel, okay, because each region, okay, C, A, S, T, is labelled C-A-S-T, cast. Okay, C obviously stands for cos, the A is for all 3 of them, S is for sine, and T is for tan. And what it actually describes is it describes the region where the angles on the curve are positive. So for instance, when we start from 0 and go to 180 degrees, you can see that for all of the graphs, the angles are positive. So 0 to 180, you can see that in this region here, 0 to 90, that sine is positive. It's between 0 and 1. And as it carries on to 180, sine stays positive. So they're all positive in this region from 0 to 90. You can see that cos is positive. You can see that tan is positive, all values from 0 sort of greater on the y-axis there. So they're all in this region 0 to 90, they are positive. But as we move past 90 degrees, only sine is positive. So you can see past 90 degrees on the sine curve, you know, sine is still above the x-axis, so it's still positive values up to 180 degrees. Okay. Cos, however, in this region from 90 to 180 is negative. Okay, so 90 to 1 is negative, so you know it's not labelled here. Okay, cos is positive in this region from 270 to 360. I'll add my 360 there. Okay, and you can see from 270 to 360, cos is positive. Tan is positive, obviously, in this region, 0 to 90, there it is. And again in this region from 180 to 270, 180 to 270, and there's the positive region. Okay. So, first of all, when I'm thinking about angles, I always think about angles as acute angles. So that's, if you want to get into my head, and it's a good place to be, if you think about angles as only between sort of 0 and 90 degrees. So when somebody gives me an angle of 30 degrees, there we go, I'll draw 30 degrees on my cast wheel here. 30 degrees for me, okay, there it is, that angle there. If someone gives me an angle of 150 degrees, well, if I was to draw 150 degrees on here, okay, there's 150 degrees turning round, I think of that as 30 degrees. So anything bigger than 90, I do a quick calculation and I take it away from 180 to find out what the acute angle would be on my cast diagram. So the cast diagram, you look at the angles turning from this x-axis, if you like, okay? So it's the amount of degrees turned from this x-axis. So that means that if we turn 30 degrees from this line, 150, okay, 30 degrees this way, that would be 210, and 30 degrees this way, and that would be 330 degrees. To me, those are the same angles. So 30, 150, 210, 330, all the same angle, okay? The only thing is that for sine, 30, and if you did the sine of 30 on your calculator, you would get a half. You did the sine of 150 on your calculator, you would get a half. And that is because, if I do it on my diagram, if I get a pencil, well, I'm going to find my pencil. I haven't got a pencil. Okay, I'll do it with yellow. Okay, if I go 30 degrees on there, up to here, you can see that comes across at a half. Okay, and go across here, you can see that would be 150, and there's my 30. They would both give you a half. These two angles, 210, okay, the same down here. At minus a half, you've got there 210, and at minus a half, okay, you've got 330. So that's your 210, and that's your 330. Okay, so you can see that they're the same, but they're just minus a half rather than a half. The same if you did the cos. You know, if you did the cos of 30 degrees, okay, the cos of 30 degrees and the cos of 330 degrees are the same angle. The cos of 150 and 210 are the same angle, but they would be negative for cos. So whereas that would give you that 0.866 root 3 over 2, if you did the cos of 30, so would 330. The cos of 330 would give you root 3 over 2. The cos of 150 would give you minus root 3 over 2, and the cos of 210 would give you minus root 3 over 2. The cast wheel continues to work. You know, this goes on, you know, to infinity, this wave. So if you go round to 360 and carried on going, you know, this is also 450 degrees, and so on and so on and so on. So, you know, you come back into the positive region. It also works if you go round the other way. So if you look at the negative I've done and you go back, okay, through here, you know, it works going round the other way as well. So this is going back, you know, to minus 360. So when we've got minus angles, you know, 330 is the same going that way as the angle of minus 30. Okay, the cos of minus 30, okay, you can see it's in the cos region, would be positive. Okay, so the cos of minus 30, and if we went minus 30 here, you'd see it be this region here. It would be root 3 over 2. Okay, the cos of minus 150, which would be this angle here, this is also minus 150 going this way, would be minus root 3 over 2, because it would have gone down here. Okay, but it's the same angle as minus 150 is exactly the same angle for all three, just 210, only some of them are positive and some of them are negative. Okay, and likewise for sine. Okay, you can see that as we go back until we get to minus 180, all the values for sine are negative, and then from 180, minus 180 to minus 360, we're sort of back up and we're positive again. Okay, so let's have a look at some values then using our cast wheel. Okay, so I'm putting the textbook here. I'm going to sort of go straight down. These values for question 3 here. Okay, oh, by the way, if I just explain, mathematicians call this quadrant 1. As you turn through, that's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You know, we always go anti-clockwise with the quadrants as we go around. So 0, 90, 180, 270, and 360. Okay, so if we look at, say, question 4, express the following in terms of trigonometric ratios of acute angles. So the first one is the sine of 240 degrees here. Okay, so if we look at 240 degrees, okay, on the cast wheel, okay, we draw our cast wheel, there it is, there's 0, there's 90, there's 180, and there's 270. No need to draw the graphs for them, okay. If we put 240 in, you know that it's somewhere in this region here, there's 240 degrees, and we just need to work out how far it is from 180, okay? And we can see that turning there, that is an angle of 60 degrees, okay? There it is, it's 60 degrees past, okay? So that is the acute angle. 240 is 60 degrees for all of the ratios, sine, cos and tan, okay? So it's the same as this one here, it's the same as this angle here, 60 degrees, okay? But CAS, oops, S and T, there we go. It's the same as this one here where they're all sort of 60 degrees, well we sine of 240, so it's the same as the sine of 60 degrees, okay, but it's in this region, so it will be negative, so whatever sine of 60 degrees is, which is actually root 3 over 2, it would be minus that. The question says express it in the terms of trigonometric ratios, so it wants it in terms of the sine or the cos or the tan of an angle. So that's what we've done. It's the sine of 60, but in this region it would be minus the sine of 60 because it's negative in this region. Only tan, the t, is positive. Okay. If we worked it out, sine of 60, as you know, is root 3 over 2. You put that into your calculator. The sine of 240 degrees, it would give you minus root 3 over 2 as an answer. Okay, that's what it would be, and that's how we use you know, the cast wheel for sort of solving. Okay, while I've got this running, I'll just show you sort of very quickly how it is used. I want you to think about you know, how we sort of, you know, you're going to go on to solve problems you know, using involving trig equations. So if I gave you something like to solve 2 sine x plus 2 is equal to 1, for instance. I want you to compare that to the equation 2x plus 2 equals 1. And we solve trig equations the same as we solve normal equations. Normal equations, we just try and get down to x. So we would take 2 off both sides. Okay, so we'd have 2x is equal to minus 1, and then we would divide by 2 both sides. So we get that as an answer. Okay, if we're solving a trig equation, we do exactly the same thing, but we just try and get down to the ratio sine x. That's what we want to get on its own. So we take 2 off both sides, same. So we go 2 sine x is equal to minus 1, and then we divide by 2 to get sine x is equal to minus a half. That's what we always do, okay? When we've got this, okay, then there's just one more step to do, and that's the inverse sign, isn't it, on your calculator, that sine to the minus 1, to find out what angle that is. But as we know, there's an infinite number of angles, so you're always asked to solve within a range, okay? Usually, not always, but usually they'll give you the range between 0 and 360. Most of our curves, you know, that we look at in textbooks are between 0 and 360, okay? So let's just say for this question, they say give all the values for x that are between 0 and 360 degrees. Okay, so they want all of the values of x between 0 and 360 degrees. Okay, when I'm solving this now, this is where I go to my cast wheel. Okay, I never put a minus into a calculator. I just think of that as sine x of a half is equal to a half. Okay, so I forget the minus for a moment and I just look at sine x is equal to a half. I inverse a half. Okay, and when I inverse a half, I get 30 degrees. So this is my cast wheel that I always draw it very quick now because I'm good at them. I've done thousands of them. They've served me well. There it is. Okay, and I inverse that on my calculator. I've got my calculator here. And I go, it's in degrees, yeah, and I go shift sine of, hang on a minute, no, forget that. Oh no, hang on, sine of a half, sine of 0.5 is equal to, oh hang on, no, shift, I've not used one of these of 0.5 is equal to 30 degrees, there you go. Okay, I've not used one of them for a while. So there's my 30 degrees. So then I draw on here 30 degrees. There it is. Okay, but then I look at this and I think, well, hang on a minute, it's not just 30 degrees, it could be 330 degrees, it could be 150 degrees, and it could be 210 degrees. Okay, so that's my 30, 30, and 30, and 30. Okay, but the fact that it's minus a half, okay, I don't want these two regions, because all and sine, that's the regions, those two are the answers if it was a positive a half, okay? And the two where it's negative a half are these two and these two, in the regions for tan and cos. Only tan and cos are positive in these two. So those are the two answers I want. So the answer is that x would be equal to 210 degrees and 330 degrees. There we go, okay? If you look at the diagram now, okay, there's my minus a half, you go across, you can see it's those two values there. And that's essentially how we use the cast wheel. Have a go at these ones here, okay? Like I say, try and use the cast wheel, but also, you know, if you look at these, yeah, try and use the cast wheel, but if you get the limits, if they're 90 or 180 or 270, you know, do draw the little graph. I'll just do one more, because I've just spotted there, you know, from there, the next one, you know, minus 80 degrees, it's asking you to find the sine of minus 80 degrees, okay? And it wants it as a positive acute angle, okay? So 0, 90, 180, 270, 360, and if you go minus 80, you're going down here, and this is going negative, okay? So this is also minus 90, minus 180, minus 270, and minus 360. So minus 80 is about there. There's minus 80 degrees. And of course, minus 80 is the same as plus 80, isn't it? Turning there, okay? So this is the same as the sine of 80 degrees, but in this region it's negative. Minus 80 is negative, so it's sine of 80 will give you a positive value, so we put a minus in front of it. There it is. Sine of minus 80 is equal to minus the sine of 80, okay? Okay, because there's a sine of 80 is your positive acute angle, and you want whatever that gives you, you want it to be minus, okay? And there's the end of my lesson today. You can watch it again. My next lesson will be on exact values, okay? So I hope you found that useful. And rewind it and watch it again if it's not, and message me if you didn't get that at all. Okay, thank you, bye bye.